Okay, this question here is talking about two wires. A force of 1, so we are having the force existing between the wires 1.6 times 10 to the negative 6 Newton act between two parallel wires in vacuum as shown in the figure 5, given that the wires each carry a current. Now, we are having two wires like this, each is carrying current in the same direction. Is okay, and the distance or the length of the wire is 200 centimeters. Now the distance separating the two wires is 2.0 centimeters. Okay. Now it means that this force, look at it, since each are carrying current in the same direction, it means that this force should be what? Should be repulsive. It's a repulsive force between the two. It's okay. If it was in different direction, it would be an attractive force. Okay. Now we are looking for the current flowing through the wires. Is okay. Now, first of all, you go inside your formula book. As I say, your formula book is your holy Bible. Is okay. I even advise you to study your formula booklet before going to write paper 1. Study it. Go and study all those formulas. Locate where all the formulas are found. Don't go in the hall. You stand now trying to locate where which. No. I'm sure that there are some formula in the formula that you don't even know that is there. So yeah, in the formula booklet they gave it as the force per unit length is okay. The force per unit length of the force per unit existing between two wires carrying current, existing between two conductor carrying current is mu I1 I2 all over 2 pi r. I think it's 2 pi r, yeah. So that is it. But here I is the same, so it is simply mu I square all over 2 pi r. I'm looking for I, so I will be equal to the square root of 2 pi, yeah, 2 pi r divided by, but then here will be F divided by L. I hope it's in now. Divided by L mu, so mu L. So that is it. I make I the subject, multiply here. Okay. Now, by doing the numerical application, I will have 2 pi times r. What is r? This is the distance. So 2 times 10 to the how many? Times 10 to the negative 2 to convert to meters. Times the force they gave 1.6 times 10 to the negative 6. All divided by mu. Now, the value of mu is inside the formula booklet. It is 4 pi times 10 to the negative 7 times L, which is the length, 200 centi. Let me convert it to meter, pardon. So since this one was even in centimeters, in fact, times 10 to the negative how many? Negative 2 meters. After the makeup, you have 0.3 amperes, making the best proposal to be B. Okay. The next question is two parallel plates each of area. So you are having the area of the plate, which is 0.04 meter square, are placed 5 millimeter apart in a vacuum as shown in the figure 4. The potential of the upper plate is, so we are looking for the potential of the upper plate. So we are having two plates. Okay, we are having the charge. Which is 0.02 microcoulombs. What are we having again? We are having the distance separating the plate, which is 5 millimeters. We are asking for the potential, the upper plate, because the lower plate is already zero potential. We are asking for the potential of the upper plate. So I think what I know first of all is that the capacitance of a capacitor is given as Q all over V. Is okay, because that is a capacitor and two parallel plates of a capacitor. And also I know that C is also epsilon D on A. So from these two formulas I can equate them like this. I'm looking for V, therefore I make V the subject. I'll have a V equals to QA all over epsilon D. Are you understanding? So from these two formulas of capacitance of a capacitor, you come out we are V. Now replacing the formulas, you have replacing Q is 0.02 times 10 to the negative 6 times the area there is 0.04. It's already in meters, that is good. Divided by epsilon times D. Okay, so divided by epsilon, we will have after doing the numerical application, So after doing the numerical application, you come out with 282 volts, making the correct potential to be D. It's okay. Without forgetting to change this distance separating the plate to 2 meters. Now let us move to the next question. So we are having two diagrams like this. We're having a bulb here, we're having another bulb here, we're having a resistor here like this. Then we are having another one here. Okay. Okay, we are having something like that. Okay, now each are having 10 ohms, 10 ohms, 10 ohms, 10 ohms, 10 ohms, 24 volts, 10 ohms, 24 volts. So the first question is, which of the following is true? A, the brightness of the bulbs in figure 7b is the same but more than those in 7a. Now, brightness here depends on the intensity of the light. And we all know that what intensity depends on power. So I should go and calculate the power on each bulb. Are we together? So if I want to calculate for the first figure, so for figure A, if I want to calculate the power on each bulb, yeah, another power will be equal to what? Power is IV, which is I square R, is the same thing. So here will be what? I square times who? Times 10. I'm calculating the power on this 10 ohms. But I need the current flow in the circuit. I know that the current flow in the circuit should be equal to V times the total resistance. Okay, V is equal to what? 24. Total resistance will go rapidly without wasting time. They are all in series. Total resistance is how many? 30. Making 24 all over 10. Is it 13 and 10 plus 10 plus 10? Okay, 30. So after calculating, I'll have 24 divided by 13. I'll have what? I'll have 0.8 amperes. So that power is simply equal to 0.8. I will square it. Then I will multiply by how many? I will multiply by 10. I'll have 6.4 watts. So that is the power reaching our 10 ohms. So each is okay. Each bulb here is receiving 6.4 watts. Okay. Now let us go for figure B. Will be what? The power. Let me choose any I'll choose any bulb here. The power flowing through this bulb will be the current flowing through him times the resistance. Is okay, times the resistance. So that is it. Here the current flowing, you should retain here that the current flowing through this 10 ohm is the current flowing in the circuit because they are all in series. They all have what? The same current. But here it's different. The current flowing through this 10 ohm is not the current of all the circuit. No, it's the current which is flowing only through 10 ohms. Now, I know that it means that here will be I squared times the resistance which is 10 ohms. Okay. Now another what? If I calculate the current reaching here, I will divide it by 2 because the current reaching here is divided into 2 equal parts because they are having the same resistance. So first of all, calculate the current reaching here. The current reaching here should be the current flowing in the circuit. Is the current coming from this? Is okay. Coming from the battery before dividing it into 2. So to calculate that current, I will simply take 24 divided by the total current flowing in the circuit, which is divided by the total resistance. Pardon. So I'll have 24 total resistance. So let us do it fast here. Total resistance here is this one in parallel. So product all over some 100 all over 20. Cancel. I will have 5. Then this is 10 ohms here, so 5 plus 10, 15. So you will give me 1.6 volts. Now we all know that what the current reaching here is now divided into what? Into 2. So it means that the current reaching the 10 ohms that I'm looking for, reaching the 10 ohms is simply 1.6 divided by 2, which is how many? 0.8. Therefore the power absorbed by that 10 ohms is simply equal to 0.8 all squared times 10, which will give me 6.4 watts. Is okay. From there we see that what? The power received by the bulb in figure A is the same as the power received by each of the bulb in figure B. Therefore, they should have what, the same intensity or the same brightness, since power is proportional to intensity. So same intensity, which is the same as same what, brightness. So as simple as that, same brightness. Now let us move to that is A. It means that A is already wrong. Now the brightness of the bulb in figure 7b is the same but more than. Wrong. It means that A is already wrong because I'm just on verifying. Same power means same brightness. Now let us go to B. B, what is B saying? B is the brightness of all the 4 bulbs is the same, but battery in figure 7 will run down faster. Okay, you should look up. The current for figure A was how many? Was if I remember, it was 0.8 amperes, and the current for figure B, the total current flowing in the circuit for figure B was 1.6 ampere before dividing to find the current flowing each of these the current flowing in each of these bulbs. So you see that who is delivering more current? B. Therefore the battery in B run down faster because it's delivering more current. Okay, I think that one is okay. Okay, student, the next question, we are having an energy level. So shows the energy level diagram for an electron in the hydrogen atom. Okay, when the electron is in the hydrogen atom, it makes a transition from energy level 4 to the ground state, emits light or frequency. Okay, this is quite easy. We know that what, when I'm leaving from an energy level to another one, the change in energy there is related to the frequency by the Planck's equation, which says HF. So the change in energy there is related to what? To the frequency, because the change in energy there, when I move from one energy level to another, there is what? Emission of what? Radiation. That radiation is having an energy called delta E, which is related to its frequency by this equation. Also, another what? Change in energy should be what? Energy, the higher energy level, which is 4, minus lower energy level. While calculating this thing, I will have a energy level 4 is a negative 0.85 minus energy level 1 is 13.0. Is okay. So by subtracting, we will have So by subtracting, we will have 12.75 electron volts. So this implies I'm looking for F. F will be simply equals to delta E all over who? H, which is 12.75 divided by H. H is the Planck constant, which is 66.62 times 10 to the negative 34. So after applying numerical application, we'll come out with 3.1 times 10 to the 15 hertz, making the best proposal to be C. As easy as that. Next question. Now the next question, we are having a sinometer wire of material density. We are having the density of the material, which is 5 times 10 to the 3. Is stressed such that the transverse waves are transmitted along it, and the speed, we are having the speed, which is 160 meter per second. The tension per unit length, so we are asking for the tension per unit length, tension per unit area of the cross section of the material is, okay. Now here, if you cannot do magic, you should know the formula that relates the speed of the string with what? With its tension. It's inside the formula booklet where we talk about wave phenomena. Please take your formula booklet seriously. Study it now. Don't go and study it in the exam hall. So yeah, I know that inside the formula booklet is C equals to square root of, I think is T all over big M. Now here we are not talking about speed of light. We are talking about the speed of the material. So here I would use V equals to square root of T on M, where this one is called the tension in the string, and this one is called the mass per unit length of the string. Mass per unit length. Are we together? Now I'm looking for, let us come here, T. Now mass per unit length, I will have mass all over what? Mass per unit length, mass all over length. But I'm not having the mass, but I'm having the density. You should already think Which relation relate mass and density? Is this now? Density is mass all over volume. This implies mass is simply equals to density all over volume. I come and replace it there. I'll have V simply equals to square root of T all over. Rather than putting this, I'll put all over L. Now, I also know that here, because they're talking about air here, I also know that volume is what? Volume is like cross-sectional area of the string times what? The length of the string divided by the length of the string. It will cancel here. So my V is simply equals to square root of T all over what? Density area. Squaring both sides to remove the square root implies I'll have V square equals to T all over density times area. I'm looking for what? I'm looking for the tension per unit air cross-sectional area. So the tension per unit cross-sectional area is simply equals to V square times who? Density. So by doing numerical application, the answer will be 1.3 times 10 to the 8 Newton meter per meter square. Newton per meter square, making the correct proposal to be C. Okay, the next challenging question is a small challenge, it's not too difficult. We are having a road like this, inclined. Is okay. Inclined to the horizontal with an angle of 30 degrees. We are having a couple of force. Like this, which is 6 Newton here and 6 Newton here. Is okay. So we are asking the distance separating. The distance of the rod is 0.4 meters. They're asking the magnitude of the moment of the couple is. Moment of the couple is the torque. Is okay. Moment of a couple is the same as calculating the torque. And that formula is given as what? Very easy. We all know that what? Moment is the force times the perpendicular distance from that force to the pivot. Are we together? But a torque is the force times the perpendicular distance separating the two forces. Are we together? So there is a difference. So this distance from moment is distance from the force to the pivot, but here is the distance separating the two forces. And that distance, look up, this force here is a horizontal force like this. Is okay. I can still prolong it here. You see that the distance separating the two forces, this is here. The perpendicular distance, it should be perpendicular. Are you seeing that the perpendicular distance separating the two forces is here? Because this force here, I can prolong it like this is him here again, going like this. Now, we also see that what? Since this angle, the angle that the rods make with the horizontal is 30, this is an horizontal line, this is also 30. So therefore, if I call this distance D, this distance D will be what? Is opposite to this angle. Therefore, without you trying to understand or without you trying to to think, D is simply equals to the hypotenuse 0.4 sine who? Sine, because opposite side, so sine 30 is okay. Coming back to our formula, I will take, when you're taking one of the force, please. You're not taking, since I put F here, you're not taking 6 times 6 no, or 6 plus 6 no. You're taking F, one of the force of the couple. So it means that our torque here is simply equals to 6 times D, which is 0.4 sine 30. As easy as that. So after applying numerical application, you come out with 1.2 Newton meter, making the best proposal to be D. Okay, the next question shows the main, okay, figure 13 shows the main distribution of kinetic energy among a number of molecules N of the gas at constant temperature. It means that the temperature is constant, and I want to measure. So this, we are having P number of molecules in a gas. We are having something like this. Okay, for a P number of molecules, we are having a certain number of we're having a certain kinetic energy. Now we are saying that for a temperature of T2 less than T1, this, the temperature here is T1, the value of, okay, you should first of all understand the relationship relating temperature. We know that kinetic energy is proportional to what? Kinetic energy is proportional to temperature. Is okay. The more the temperature, the more the molecules have what? Kinetic energy. Is okay. The more they are mobile. Now, if the value of the temperature is reduced to T2, P will increase. Is it correct? The number, because understand, P is the number of molecules present in the gas at the temperature T1. It means that if I decrease the temperature to T2, will the number of molecules reduce? No, it's not making sense. The number of molecules will still stay there. The problem is that the number of molecules now will lose in energy because the temperature has reduced. Because what? Temperature is proportional to kinetic energy. Therefore, it is Q that will what? Q that will decrease. Loss in energy because temperature has reduced. Since temperature is proportional to energy, Q will reduce, making T to be correct. Now, 3 also is correct because the number of molecules will never, it does not depend on the temperature. No, the number of molecules will never reduce or increase. So it is constant. P is constant, making also 3 to be correct. 1, 2, and 3 are correct. I think the proposal should be B. Next question. Okay. For the next question, we are having a circuit diagram. Let me draw it. Six volts here, 3 ohms, 4 ohms, 6 ohms, 1 ohms. Okay. So this is a circuit diagram. It shows an electric circuit. The reading on V is, we are asking for the reading of V. It means that you are placing your multimeter here. It's okay. You want the voltage across these two ends. The voltage across these two ends is simple. PD, potential difference. It means I'm calculating the PD. So V is calculating the PD between these two ends. And this two ends is related to this resistance and this resistance. So I'm calculating the PD between the potential difference between 3 ohms and 4 ohms. Or it can still be the potential difference between 1 ohms and 6 ohms. So I'm subtracting. It's okay. PD, potential difference. Difference means subtraction. Okay. Now from here, don't bother about the sign. If I'm taking V3 minus negative, remove the negative. It means that we're supposed to invest in that V3 was more than V4. Don't bother about it. Okay. Now, please, from potential divider, why am I talking about potential divider? I did it in a previous video. It's very easy for us to use potential divider and come up with the answer here. Don't go and take each of you waste time for nothing. You don't have time in paper 1. And this is a challenging question. Don't have time. Now, this 6 volt here is parallel. It means that I can still say that the 6 volt is coming here again like this. It means that this terminal here is the same as this one here. Is the first of all the same here, and is the first of all is still the same here. So this 6 volt here is the same as connecting 6 volt here like this, a battery here. Then this one in series, this is not a junction, please. It's not a junction. It's like you're placing a multimeter. At any time you can remove it, so it's not a junction. Therefore, these two are in series. And if they're in series, they should have different voltage. It's okay. They should have different voltage. Therefore, they are sharing who? They are sharing this voltage in proportion to who? To their resistance. Okay. Now, if I'm looking for V3, as I said in my previous video, to apply voltage divider is simple. You come here, you want who? The voltage across 3 ohms, you write your 3. He's sharing with who? With 1 ohm. Therefore, since they're in series, I will take the sum, 3 plus 1. Then he's sharing who? 6. It's like you're sharing something amongst two students. So here I'll have now 3 all over how many? 4 times 6. So 2 can cancel here. I will have 6 all over. I think it's in now. 2 cancel here, 2 cancel here, 3. Okay, it's 9 all over 2 volts. Now I'll go down to V who? V4. V4 will be simply 4 all over. He's sharing with who? With 6. He's sharing who? He's sharing this 6 volt. So it will be 4 all over 10 times 6. 2 cancel here 5, 2 cancel here 3, 12 all over 5 volt. Therefore, my V is simply equals to 9 all over 2 minus 12 all over 5 volt. Making the answer to be, you see the answer will be negative, but don't bother. Okay, making the answer to be negative 21 all over 10. You remove the negative volt. So 2.1 volt. Making the best proposal to be B. As easy as that. Somebody that will go and 10 Kirchhoff there is your problem. You waste time for nothing. If you don't master potential difference, go and watch my video under potential difference. There's a playlist there of physics only. If you enter inside the playlist of physics, you see there is well arranged in order. Okay, for the next question, we are talking about potentiometer. I still did a video on that potentiometer, so you people should go and watch it. It's very interesting. We are having a potentiometer. We are asking for the PD between the ends A and B. I told you that what? At balance point of a potentiometer, the voltage is proportional to the length. It means that the voltage across AB divided by the length AB is simply because the voltage across the end AC divided by the length AC. I'm looking for the voltage across AB. Very easy. So voltage across AC times LAB divided by LAC. So by replacing, I'll have 1.5 times 100 centimeter divided by 60 centimeter. No need to convert from centimeter to meter because it will cancel out, making the answer to be C. Making the answer to be the C proposal, 2.5 volts C. Next question. Okay, next question, talking about show a straight wire passing through a piece of cobalt. The wire carries a current I. Okay, this is quite easy. I think this is from 5 now. I think which of the following is correct about the direction of the magnetic field. Now, to find the direction of the magnetic field here, I have a conductor carrying current going downward. The best rule you can use high hand grip rule. When you use high hand grip rule, look at how I'm doing. Since current is going down, the thumb is representing the current. I'm going like this, clockwise. You can use the hand grip rule. You see that the direction of the field will be clockwise. Or you can use the corkscrew rule. It means that I'm having maybe a bottle like this. It's okay. Since current is going downward, I hope you understand. Since current is going downward, I'm not opening. I want to close. The current is showing the direction of my cork. My cork should enter. It's okay. So to close it, I should move what? Clockwise. Are you seeing? Clockwise. If the current was going up, I will open what? The cork of the bottle. When I'm opening, you see that it's anti-clockwise. So that current should go up. So that the cork should go off. Now, for the cork to enter, current should go inside. I should close it. Therefore, clockwise movement. So that is it. So the best proposal there should be what? It is a clockwise according to Maxwell corkscrew rule, making the best proposal to be D. Now, the next question, very interesting question here, is under diffraction of light. We are having two waves of same wavelength lambda, constant phase difference, and same amplitude. There is a condition for interference to occur. At the level of the screen, we can also see that at the level of the screen, interference occur. Let's say we are having succession of up here, we are having a bright region. At Q, we are having we are having a minimum region. It means that a dark region. At R again, we are having another bright region. This is X and Y. Now, I want first of all to remember you that the conditions for us to observe a bright region or a maximum is okay. For us to observe a maximum, the path difference, which is called delta X, should be for bright region. Is okay for us to observe a bright region or maximum. This is the condition. The path difference between X and Y, I will call it a path different path. Yeah, XY, I will call it maybe delta. Normally it's called the delta D, path difference. Should be written as what? As whole number of the wavelength. Should be written like this. As whole number of the wavelength. Is okay. But for destructive interference or for dark regions or for minimum, you see that what the path difference here should be written as who? Should be written as odd numbers. Odd numbers of who? Of half the wavelength. So that is it. I'm just from summarizing already and not like that. So if you people, I really talk about it in my previous video when I was talking about superposition of waves. So you people should go and watch it quickly for quick revision. So yeah, the path difference is written as a whole number. Anytime the path difference will be written as a whole number of the wavelength, we will we will observe a bright region at the level of the screen. But anytime it is written as odd number of half the wavelength, we will observe a dark region at the level of the screen. Now let us come back to our question here. The first statement is saying that XP should be equal to YP. Such an observation may be obtained if such an observation may be obtained if XP is already wrong. First of all, they are showing that the path difference here is already 0. It's wrong. We cannot observe interference of we cannot observe succession of bright and dark regions if the path difference is 0. Now, the next is y cure, minus x cure should be written as lambda 2. Is it correct? Look at this is like this, like this. It means that this is the path difference between them. Is okay. And to calculate it, I will take x cure minus y cure minus x cure. It gives me this path difference. Now at cure, what are we having? At cure we are having, is it a maximum? Okay, we are having a maximum at cure. So we should hold this condition. Is it? It's already wrong. It means that we cannot observe a maximum there because the path difference x cure minus y cure minus x cure is not written as a whole number of the wavelength. No, it is half the wavelength. Half is not a whole number. Now let us move to the third one. The third one is saying that yr minus xp is written as lambda all over 2. This one is very correct because if I calculate the path difference between here and this, okay, this is where the interference is formed. If I calculate the path difference, this is it, yr minus xr, the path difference here, yr minus xr. Since here is a minimum which is formed, I should have what? The answer of that path difference should be written as an odd number of half the wavelength. Example, when n takes the value 0 here, the first odd number is 1. So I'm having 1, and they have the wavelength, making the second statement to be very correct. So that is it. As simple as that. So you should cram the conditions for us to have maximum and minimum regions. Now, for the next question, we're having the Earth satellite of a mass revolved at a height h from the surface of the Earth. If r is the, okay, it means that we are having the Earth, we are having a satellite which is resolving here like this. Then it is resolving from the surface of the Earth, not from the center, h. And we all know that what the distance from the center to the surface of the Earth is what the radius of the Earth. This is the satellite. This is the Earth satellite. Is okay. It means that for the satellite to go around the Earth or to resolve to the Earth is okay. There's something that should happen because there are two forces here. The Earth is pulling the satellite toward him. That is it, because the Earth is a bigger mass. It is pulling the satellite toward him. But why is it that the satellite is not falling on the Earth? Because the satellite is moving. It's okay. So it is being balanced by the movement of the satellite. And that movement of the satellite is due to what? What we call the centripetal force. So the centripetal force balances what? The gravitational pull of the Earth on the satellite. The force of the gravitational pull on the Earth on the satellite. Okay, so that force is being balanced by this one. It means that Mr. mv square all over r equals to gmm all over r. Now you should look up. Small r is different from big R, please. Small r here is the radius described by the circle of the satellite, like this, something like that. So it is that radius, the distance where the center of the circle of the satellite is the center of the Earth. So the distance r is simply equal to what? Big R plus h. I hope you are seeing. So the distance small r, which is the radius of the circle described by the satellite, is equal to big R, which is the radius of the Earth, plus h. That is it. Big R, radius of the Earth. So here, by the here square, here we cancel one time. So I will have a v square simply equals to gm. Also cancel. The mass of the satellite is not important. V square is equals to gm all over r. But I know that the radius of the satellite is the same as r plus the height above the surface of the Earth. So it means that my v is simply equals to square root of gm all over what? All over big R plus h. Now there's no proposal. Okay, it means that I should also. It means I should break down again something. Another one, the gravity on the Earth's surface. The gravity on the Earth's surface is gm all over who? All over the radius of the Earth square. That is what I know. Then from here I can make gm the subject. Gm is simply equals to gr square. Let us go and substitute and see if the answer is coming out. So I will have gr square all over r plus h. Let us see if there's any proposal. Okay, making the best proposal to be B. As simple as that. So if people understand that centripetal force equals gravitational force, from there you derive, you have your mark. we are having a set of graphs. The state of an ideal gas was changed. The state of an ideal gas was changed 3 times at different temperature. Figure 1 represents the 3 different isothermal curves. Which of the following is true about the temperature of the gas? Which of the following is true about the temperature of the gas? Now, something is very, you people should understand here. No need even to come up with calculation. No. This is what you people should know. From PV equals to nRT, it means that P equals to nRT all over 1 all over V. It means that if I'm plotting the graph of P against V, I'll obtain what? I'll obtain curves. As you people, as I said in my previous video, is okay. Any graph in the form Y inverse proportional to X is what? A curve which is not touching, which is neither having a y-intercept nor an x-intercept. This is it. And that should be a difference between a decay curve, because a decay curve is having y-intercept. Is okay. Why? For this one type of curve, there is no y nor x-intercept. I explained it yesterday. People should know. This one is a graph. It's an indirect proportion graph, like this. This is it. Okay. Now, from there, you consider the gradient here. This is the gradient. You consider the gradient of our graph is this one. Are you seeing? And the gradient depends on who? Temperature. It means that we all see that what? The more the graph is going upward, or the more the graph is up, the gradient is more important. It's like the gradient here. Let's say the gradient of M3 here is greater than the gradient of M2. It's greater than the gradient of M2. And since the gradient depends, is proportional to what? The temperature, because look at the temperature is found where we are having the gradient. Therefore, we conclude that what? T3 is greater than T2, which is greater than T1. As simple as that. You have your mark. Making the correct proposal to be C. Okay, now next question. Okay, the next question, the value of X for which the galvanometer in the figure 4 shows a null deflection. Null deflection means that the PD across its end is 0. As simple as that. And if the PD across its end is 0, remember, that the galvanometer is measuring the potential difference between X and 4 ohms and between 6 and 3 ohms. It means that if the PD there is 0, it means that the voltage, normally the galvanometer should be equal to the voltage across X minus the voltage across 4 ohms. If this is 0, it means that the voltage across X should be equal to the voltage across 4. Now, from potential divider, if I let maybe the voltage should be 4 there, from potential divider, if I want to find the voltage across X, since X is in series with 6 ohms, I will have X all over 6 plus X times V, and the voltage across 4, since 4 is in series with 3 ohms, I will have 4 all over 4 plus 3 times the voltage being shared, which is V. Now, equating the 2 here, I will have X all over 6 plus X V equals to 4 all over 4 plus 3 is how many? 7. V can cancel across multiply. I have 7X equals to 4 into 6 plus X. Okay, I open the bracket. I will have 7X equals to 4 times 6 is how many? 24 plus 4X. Then when I subtract, I'll bring this one here. 7X minus 4X is giving us 3. 7x minus will give us here 3x equals to 24. I divide both sides by 3. Therefore, that resistance should be 24 divided by 3, which is how many? 8 ohms. As easy as that. Okay, students. So that is all about some challenging question that I wanted that we should work on it. I hope that it will help you in your exam coming on Saturday. So good luck for your exam. We are together.